So, hi, and welcome everybody to the second part of this tutorial about game engines for visualization. Here we have Xavier Martinez. He's a postdoc at and I hope I don't completely mess up here, Laboratoire de Biochimie Théorique. No, I probably messed it up. You can do it better afterwards. In Paris, France. He's working on molecular visualization. And as part of his work, he's especially working on a project called UnityMol. As the name suggests, a molecular viewer, molecular visualization tool based on the Unity game engine, which also provides virtual and augmented reality functionality. And so today he will tell us a bit about using Unity for visualization. And there you go. Stage yours. Thank you.
Thank you very much, Michael. So as you said, I'm mainly working on Unity. So of course, my talk will be focusing on Unity. Patrick did a great job at introducing, the small differences between Unreal and Unity. So I'm not going to go over that again. I would just say that for me, I think it's easier to learn Unity just because of the C# language that is used in Unity, to script things and to program basically. Unity also has a sort of huge community, a lot of free and paid asset with a star, a bit like Unreal Engine. So it's quite easy, to start with, and also go further. And for example, you can change the editor and add some buttons or do customizations on your objects or on your UI windows. So you have a power to do a lot of different things in Unity just by scripting things with C#. So also Patrick mentioned a lot of things about performance, and this was kind of an issue at some point at Unity. They recently introduced a sort of new ways to do C#, but high performance C#. They introduced their burst compiler. It basically translates some .NET bytecode into optimized native code. Well, the idea is just to have a slightly modified subset of C# to be able to have sort of the same performance as C++. And this is also what I experienced using this framework. I have at least the same performance as C++ and sometimes better. This is quite convenient when you deal with large data and large scientific data that you want to process in real time. So you can even do some processing in Unity instead of doing that outside and then import the data. So one thing I also wanted to mention is that for performance reasons, sometimes, or even if you have developed a library outside of Unity, you can call that, because the C# language gives you the opportunity to use the native code and compile it as a shared library and use that inside Unity. So you could basically have a full library with high performance code like CUDA, OpenCL, or OpenMP, or whatever, and use that inside Unity quite easily. So that's one way of seeing Unity, is maybe just do the rendering and take care of the data processing and data importing in plugins that you already developed outside of it. Also, to go back to the specifics of Unity, I would say that it's also a nice platform to develop shaders on, because you have several cross compilers that basically you can develop in CG or in HLSL or GLSL, and it will cross compile it to some code that you can execute on basically every GPU that there is. It also has asynchronous compilation, so you can modify a shader and instantly see the result of the modification in Unity. We'll get through that in sometimes if I have time at some point. And of course, you also have some visual scripting languages like in Unreal. So you have basically a shader graph to create some shaders without coding. And they also released recently a way to do that for C# scripts. So if you don't really want to develop some code in C#, you can have this visual scripting language and just do it visually. Also, Patrick covered the reason why we would want to use game engine for scientific visualization. There are some points, of course, we want to pay attention to, like importing data in game engines. As I said, the community is quite large, so there is a good chance that you will have some plugins to import your data, to parse some JSON data, for example, or stream some things from the network or even from your disk using Unity plugins. There are also several toolkits, visualization toolkits to deal with all that. So there are some efforts in Unity, usually open source. So go check them and see if there's something you can use and customize and modify just for your needs. So for example, in Unity Mol, the molecular viewer I'm developing with Mark Baden in Mark Baden's team, we used a lot of C# to import and to parse the files that we read. So mainly PDB and GROW files, molecular files, basically. We also have some plugins that we didn't develop, but we adapted to Unity or from Unity to export data or load some OBJ or FBX files, for example. So one thing also about Unity that is really good and also really nice in Unreal is that you have access to a lot of different platforms, as Patrick said. But not only VR and AR, you also have Android and iOS, basically for free. It's not really for free because you have some catches. For example, the shaders that you developed, you strictly have to follow Unity's ways of creating shaders. Just some macros that simplify the work you do in shaders, but that are really essential because there are some differences between OpenGL and DirectX, for example, in the shader code that you really don't want to deal with, and Unity is dealing with for you. You also have to deal with a WebGL way of storing data and getting data in the web browser. So there are some examples. The good thing is that there are some examples that you can use in Unity to just get started with and go through it with. All right, so I think I will go through my sort of tutorial, but the idea was to provide a sort of a start and then ask you what do you want to see more and what things you want to see in Unity that we can quickly do in this short tutorial. So yeah, the idea is to show how it's quite easy to start with Unity, but you will eventually face some performance issues, usually in data visualization, because we don't usually just visualize, I don't know, 100 cubes. So the good thing is Unity is providing a lot of tools to overcome these limitations, and the idea of this tutorial is both to introduce you to Unity and what you can quickly do with it, but also to give you some tools to optimize things and have not only a prototype, but maybe something that you can actually use. So let's start with Unity and basically start to download Unity. There are two ways to do that. The idea is to use the Unity Hub to do that, just because it's a packaged way to deal with all the scenes, all the projects that you're going to create, the license, but also the different versions of Unity. So I just downloaded Unity Hub. I already installed it, so I'm going to replace it, and I'm going to start it right now. And as you can see, so if this is the first time you install Unity, you will have to deal with the license. So for this tutorial, of course, we can choose a free license and go with the free license. I will. So if it's the first time you install a Unity, you will have to install actually a version, the latest version of the 2019 of Unity. So here I only have the .4.11, .10, so you can install the .11. Shouldn't be an issue with this tutorial. So let's say you already have installed it. You're going to be able to create a project. We're going to use the standard template, the 3D template, just for this example. I'm not going to use the latest versions of Unity running pipeline just because it's simpler for me to start with that. So I will just create a project named Tutorial VCBM 2020 on the desktop, for example. All right. We can close that. I'm going to copy paste the backbone of the script. I'm using an external editor to code, basically. You can change the options in Unity to set basically what editor you want when you double click on some script that you want to edit. This is a good time to actually answer the questions that I just got. I don't have any experience with Activiz and Unity, so I checked it. I think it's really interesting. It's a lot of work because what they did, so basically what they did is they wanted to use VTK inside Unity and basically make them communicate. What they did is actually they did the rendering, both the rendering in Unity and in VTK, and they write to the frame buffer from VTK. So as I said, in Unity, you can have native plugins, but you can also do some renderings in OpenGL or in DirectX or whatever outside of Unity and write to the frame buffer in Unity. And this is basically what they did, which is a lot of work, but it's also pretty cool because you have access to some VTK functionalities. So now if we go back to the main example I wanted to show, there are some. So this is basically the main windows, the main layout in Unity. You can change the layout, so you have the hierarchy panel here, where you can see, for example, the main camera. If I click on the main camera, you can see I selected it here. This is the scene view, and this is the game view. So this is what your camera is gonna show. You can of course change the parameters of the cameras or on the light. If I change, for example, the position for directional light, doesn't really matter. But this is an example. You can switch there. And this is the project view. So in the project view, you're gonna see all the different folders and all the different assets that you can import and that you can use in Unity. So I'm going to create some folders that I will need later in the tutorial. I'm going to use the scripts folder. So I'm also going to create the resources folder. This is the folder where you can basically store some data that you're going to import at runtime. So I already have the scene folder created. I can create a new one. So let's create a new scene. I don't care about the modification I just did, and I'm gonna click save. And I'm going to save it to tutorial, scene 1. Okay. Now I'm going to create some scripts to be able to create some spheres. So the main idea of this tutorial is to show you for example, a small prototyping of showing spheres that, for example, you have, I don't know, a sort of data that can be shown as a sphere, and you want to do that in Unity. So one way of doing that is the naive way to do that is to basically create spheres and set the positions for each spheres and see how it goes. So let's call it sphere naive. Unity is working with game object component approach. So basically, each thing in there, it's in the hierarchy, is a game object. So if I create a new game object, I already have a component for each game object that is a transform, and I can add component to this transform that will act on the game object itself. So I already created a script there. I can drag and drop the component that I just created to the game object. So now if I click on the game object right here, I will see that this game object has a component called sphere naive that I just created. Let me just check the questions. Okay, no questions. That's good, I guess. So now if I hit the play button, I will start the Unity game engine and I will see if the game is actually doing anything. It shouldn't be doing much thing. So let me just hit play. Right, so it started. I can move the camera around. So let's move the camera. You can see that everything is moving and running. So now I will edit the script that I just created and do something. I'll just copy paste the code that I already created, backbone of this example. The idea is to have a number of spheres to draw, and we will give them positions. So I have an array of positions. So vector 3 is like a float 3. And I have a list of game objects. Actually, I'm not going to use that. So let me just delete that. And I have a function that is called at the beginning of the game when you start the game, basically. So this is the start function. In this start function, we'll do the allocation and these kind of things. We'll fill the positions, and then we will create the spheres. So let's write how I how I fill the position. So I'm just going to allocate this array. This is a vector 3, and I will need n spheres. Right? I hope you can see what I write. Let me make it bigger, maybe. Okay. Now I will just fill the positions with some random data. So in this part, the idea was to simulate the way you would import data. You would read a file, for example, or get a stream or fetch some data online or something, and you would use it at some point. So let's create, let's fill the array of positions. So this is really close to C. So if you're familiar with C, you can just guess the way of writing things. And I will fill the positions. So I will fill that with a new position. And to do that, I will use a random position. So you can use that. So here I'm getting random data between minus range and plus range. And I have to define range, of course. So let me define range equals, let's say, n spheres divided by 100. Seems good. And yeah, so here now I have random positions for each sphere. And I will actually do the magic and create the game objects at this point. So Unity has, it already has some predefined objects. So for example, I can move to Unity now. I didn't mention, but by default, Unity is recompiling the C# script that you just modified. Every time you you click on Unity. So every modification you do, so for example, I'm just going to remove some space here. It's just going to recompile the scripts and everything that is in your folder. So I wanted to show you that you can have predefined objects. So you have a cube, a sphere, a capsule, etc. And you can, of course, use that from the C#, code. So I used, let's create a game object, name game object. And Unity's way of doing that is create primitive. And I have primitive type sphere. Okay, and now I will give it a position. So to get a component in Unity based on a game object, you usually do get a component like that, and you give him a type. So I could do that, but the shortcut to do that in Unity, as you usually get the transform component allow usually to that transform, and you can set the position just by saying I'm on this position. So now let's use that in loop. So of course I'm going to use the position the I loop iteration. So let's create for. I'm just going to use the positions that I just created, and here you should have spheres at the right position. So I guess there are a lot of different typos. Let me, oh yeah, so I have to use game object. If I recall correctly. Yeah, so let's try to hit play. And here you have, I think I set it to 1,000. So you have 1,000 spheres in Unity in like 10 minutes of work. So that's pretty good. And as Patrick mentioned in his talk, we have an issue here because for each game object that we created, we have a material. So for each game object that we have a draw call. So let's see how many draw calls we have. So as you can see, if you click on the stats button here, you will see a small window that shows some information about how many time you use to how many time you spend just creating this frame, how many triangles you draw, how many FPS you have, basically. So you can see that I have 4,000 patches, so 4,000 draw calls. So that's not really good, and it's way more than 1,000 because we have the shadow mapping. So maybe if we can just disable the shadows, we'll drop to 1,000 here. Oops. So yeah, we have 1,000-ish, just because I think I have some game objects somewhere. Yeah, I think the skybox also uses one draw call or something. So let me check the questions. So one question by Kira Kosek. I see you don't store your new game objects anywhere in the properties of your script. How do you access them in updates? So here I just created one script that has, I just created one game object that has one script, and this script will create 1,000 game object. If you don't want to do that, so you can create a game object and assign a new component to it, right? But maybe that's not your question. So how do you access the positions, the component in for each game object? So this is this line actually. So I created this line, and I use the position of each transform. But I agree, if you want to use it in update, you're gonna have to store them somewhere. So this is why I had this list of game objects that I will call smartly game objects. Let's pre-allocate it. This is a list, so we don't give it a size. And you can add things to your list here, and I will just use that. So now, if I do it correctly, each game object should be in my list. Or I can make it public just to be able to see it in the editor. So here I have a game object. So I didn't start the game, so this is empty for now, and same for the positions. But as soon as I will click the play button, you will create the game objects, but you will also set these arrays and this list. So if I, for example, if I click on this first game object, I indeed have this game object at this point. So now we have 1,000 objects in Game Engine, but you kind of want to have some dynamic data. So let's say we want to move them around. You usually have, I don't know, some inputs from the simulation or something that you want basically the data to move. So I'm going to use the random positions again, just because it's simpler in this tutorial not to come up with a sophisticated algorithm. So now let's loop on the position I created, or on the game object. Let's loop on the game object. So it shouldn't be hard because it should be the size of n spheres as always. I can also use the size of the list to loop on. And I can also do this game object geo in game objects. So these are two ways to loop over your list of game objects. I'm just going to use the first one. So let's say we want to move them quite a bit. So I'm just going to use the position thanks to the transform. And I'm going to assign a new position. So I'm going to use vector 3. Or let's say I want to use the previous position, but just add things to this. I'm just going to use plus equals, and I'm going to create a new random position again. Let's call it random.range. I'm going to use delta. Yeah, I'm going to use delta. And once again, I'm going to copy paste because I'm too lazy to write this down. And again, right? So now I have to, of course, define delta. Let's create delta with, I don't know, this. And here we should see if I start again. So if I switch to Unity, this will recompile, and I should be able to see things moving around. Okay. So if I change the position of the camera, things are moving. So yeah, that's good. If you have some questions, I didn't mention it, but if you have some questions or things you want to see, please ask the questions in Discord. I also supposed to watch the Zoom thing, but I'm not really checking. All right, so as you can see, well, it's running on my computer because it's not a strong computer, but it's not so bad too. The idea is to show thousands of spheres, and here we only have 1,000. It's already taking 5 to 6 milliseconds to render the frame. So that's not really what we want. And the idea is to show that in Unity, it's quite easy to prototype, as I just shown. But if we want to improve the solution and be able to draw thousands and thousands of objects, you kind of have to optimize it. The good thing, as I said, is Unity is providing a lot of tools to do that. One tool we can see is the profiler. So let's jump into the profiler. So if you click on the window and analysis and profiler, it's going to open a new window. So this is running and catching the information in my screen right now. And if we can click, this is the CPU information you will get. You also have the hierarchy of calls in the game. So here I just clicked on one part of this CPU usage graph, and you can see that it poses the Unity game engine. And if I click on player, you will see some information. So the camera is actually taking quite some time to render. The fixed update is also, so fixed update is the update loop for the physics engine. Weirdly, it's running, but I don't use the physics engine. And this is because I have spheres with sphere collider. So it's actually synchronizing the sphere collider for the physics engine that runs, even if I'm not using it. So that's one information we can use to optimize the game. So it's not taking so much, but it's taking 1 millisecond. We also need to, of course, to improve the rendering for that. So instead of having one material for each game object, we kind of want to have one material for all the game objects at some point. One thing I also should mention is that the profiler is running in the editor, but you kind of want to optimize it outside of the editor, because the editor is taking some resources and it will not show you an accurate, really accurate way, profiling of your solution. So you should basically build a solution. I can show you how to do that. I'm just going to click on File, Build, so Build Settings. I'm going to add, so you can choose what things you want to add to this build. This is going to create an executable. So I'm on Mac. I didn't mention it, but you can also build it for Linux, for Windows, etc. And you have a list of supported platforms here. So I didn't install everything during the installation, but of course you can do that afterwards. So I'm going to create a build. I'm going to create a folder named test build, because I'm usually call that, and let's call it sphere 1. It's going to take a while to actually compile the things I'm going to need. So the shaders, etc., are compiled for you. The C# code script, the C# code is also compiled and bundled into this executable. So now I should see that in the file browser, and if I start it, or I think yeah. So this is gonna using, okay, that's well. This is gonna be using the full screen mode. I didn't check the settings. And here, usually when it's pink like that, is that the shader is not compiled on your computer. So we can of course change that and fix it. And yeah, the idea was to show that you can check this development build thing and click auto connect on the profiler. And if you want to have even more accurate way of profiling your game, you can click on that. And this will, if you have this analysis profiler window, it will auto connect to this and run an accurate profiling of this code running. So this was a way to profile your code. So now if we want to be able to improve the rendering of this, I prepared a sort of scenario where you create a prefab. So this is basically prefabricated object. So let's create a folder in the resource folder. I'm going to pre-create a sphere. And I'm going to remove the sphere collider because we don't really need it. Remove component. Here you go. And I'm going to, so let's open the prefab folder. I'm going to drag and drop this prefab inside there. I'm going to call it sphere prefab. Prefab. Oops. All right, so the name is actually important because we're gonna be loading that from script. So let's remove that from the scene. Let's save the scene and create a new one. So new scene. I'm gonna save it and call scene. Let's call it tutorial scene 2. All right. I'm also gonna create a new script named sphere batching. Okay. Unity is creating the script and already compiling, as you can see in the lower part of the Unity window. I'm also creating a game object to attach. Let's call it start create spheres. All right. Oops. And I'm gonna drag and drop this new script that I created, and I'm gonna edit this script. I'm just gonna copy past basically everything but the first public class line. And the reason is that the name of the class is actually have to be the same as the name of the file. So here we still have the thousands objects created. We create an array of positions. And instead of creating a primitive based on Unity way of creating things, I'm gonna load this resource prefab sphere prefab. So to do that, you have to instantiate the game object. So let's create instantiate. And then I'm going to load the resources from the resources folder. So to do that, you can call resources.load, and then you give it the path. So this is prefabs and sphere prefab. All right. And we see how it goes. So I didn't mention that I have a window console here, so you can check the errors, the warnings also. So sometimes you have some warnings. Here I have an error, just a small typo, I guess. Oh yeah, so probably forgot one line. I still have an error, instantiate. Small typo, I still have an error. So yeah, I have to instantiate as a game object because this is a game object. All right. So now it's compiling. I'm checking, let's remove that. I'm checking that my script is still there and I can run it. So we shouldn't see any difference here, all right? We still have the same performance, etc., because basically didn't change anything but removing the sphere collider. The idea is to have one material for each, for all the spheres. So let's create a material. I'm going to create a new folder named materials. And I'm going to create a material here, create material. Let's call it sphere material. Nothing fancy. And what you can do is edit the prefab to use this material. So let's double click on this. This will open a small scene view. And we're going to drag and drop the material directly on the prefab. So this is working because we have a mesh renderer and a mesh filter here. And on the mesh material, you can see that I have one material attached, and this is the sphere material. All right. Let's save. And let's run again. So now I should have only one material. I already halved the, or maybe not. No. So I still have one material, but I think it's instantiated for each game object. So to avoid that, one way we can do it is enable this. Enable GPU instancing Because as you will see, it's actually not doing exactly what we want. So now we only have 12 draw calls. So this is way better, and we should have better performance too. This is due to the fact that Unity is recognizing that the materials are all the same, and it's batching them. So it's basically grouping them into one draw call or 2 or 4 draw calls, but way less draw calls that we used to have. It's still not GPU instancing, so it's done on the CPU. So we could go further and see how to actually do GPU instancing in Unity. At this point of the tutorial, I also can provide a way to. I also can show you how to actually do some shader coding in Unity. But this is your call. So just tell me in Discord chat if you prefer to see GPU instancing in Unity, or if you prefer to have some initiation to shader coding in Unity. While this run, I can give you a sort of overview of all the things that you can have in Unity. So maybe not all the things, but interesting things. There's a new thing called Package Manager. And here you have a lot of things given by Unity to improve or extend Unity's capabilities. You have also the VR and all these AR packages that you can use, but you can also have some better audio. You also can change the rendering pipeline. So this is a new thing in Unity. You can change the rendering pipeline. So if you are running on mobile and you want fewer things, like you don't really care about the accurate shadow mapping or this kind of thing, you can disable it, and you can basically optimize Unity just for your purpose. Let me check my notes now. Oh, maybe one thing we can quickly show is how to do post-processing, have some visual effects in Unity. So this is actually a package. So if I open the package manager and install the post-processing effects, I'm just going to install it. This is basically some C# code with shaders, and I should be able to use it soon. Takes a while to import everything. Right. So as you can see, I have now I have a new thing in my packages folder, which is post-processing. So to use post-processing, you need to add some components to the camera, and you need the post-processing layer and a post-processing volume for your scene. So I'm gonna click on is global because I want this to be drawn on everything, and I'm gonna use a new post-processing profile. All right. This is already set. I'm going to set it to everything because I want once again to see the result on all my scene. And I'm going to use an effect. So let's add, for example, some bloom effects. This is always cool. And I want to add some, let's add motion blur. Motion blur is always fun. So now if I click on play, I should be able to see motion blur and customize the motion blur. So to do that, you have access to some settings here, and you can, for example, lower the shutter angle let's put it to max. And you can also change the quality of the motion blur. Same for the bloom. I should be able to add some intensity and already have a nice effect. All right, this was for the post-processing effect. Of course, you can add things, and you have pet asset or free assets that you can download on GitHub or on Unity. I don't even remember the name, Asset Star. And you can also create yours. All right. So I didn't get many answers based on the shader or optimize things. So let's do the optimization, and let's do GPU instancing in Unity. So the idea is always to have data, a large set of data, and to be able to show that in Unity. How would you do that? So of course, we would start with the naive way, and just basically draw some spheres and see what happens. And at some point, either you buy a new computer because it's too slow, or you optimize it a bit and you try to basically use GPU instancing to run a lot of objects, basically. It doesn't have to be spheres, of course. So to do that, we're going to create a new script. So let's go back to Unity and create C# script. Let's call it sphere instancing. Right. We're going to create a new scene again. New scene. Okay. And say scene. I just got a question from Patrick. GPU instancing supports LOD of the prefab. So yeah, you can define how instancing is done in Unity by also adding some LODs. So I'm just going to finish typing this and talk a bit more about this. Let's call it tutorial scene 3. Add some game objects and add sphere instancing to this. Create sphere instancing. Okay, seems good. So yeah, I didn't talk about all the animation and all the LOD stuff in there, but you can indeed have really complex scene and have some LODs to that. So you can add prefab. Let's modify the prefab and add some LODs. You can add LOD group and basically change the submesh. So you can change the mesh in there and have a simpler mesh to do some LOD. And this is going to be working during instancing. I didn't check it, so I have to check it to be sure, but should be working. So now back to our scene 3. We are going to once again use everything there. I'm going to use the script that I just created. It's empty right now, so let's fill it with that. What we are going to use, so I'm just going to be able to use another computer at the same time because I'm cheating. All right. So what we're going to do is we're going to use the same backbone. We still have the position, but what we are going to do is use the transformation matrix. So as Patrick said, you usually have in GPU instancing, you need the same mesh, but you need a transformation matrix to change the position, the rotation, and the scale of your objects that you want to instantiate. So let's create a list of, or not a list, maybe an array of matrices. So in Unity, you can use 4.4 matrices. And it's an array, so let's call it transform matrices. And okay, so let's do the allocation later. We're going to do the allocation just here. New matrix. We still have one matrix for each sphere. And now we have a position. So we're gonna fill this transformation matrix array with a new matrix that we'll call M. And M is a new matrix that for. We're gonna set the matrix with set RTS, rotation translation scale. Oh, it's actually TRS, translation rotation scale. And for that, we need, of course, a position that we already have. That is this one. A rotation that will be just nothing because it's sphere. We don't really care. Identity. And we use all the same scale, that is 1. All right. So here we should be able to create this transformation matrix. We are going to use the mesh that we're going to instantiate. So instead of creating game objects here, we are just going to use the game object here to be able to get meshes from a game object. This is also the way to actually modify the mesh. So I can also show how to dynamically modify the mesh while it's running. So we'll do that later, maybe. Let's get the component I was talking about. So this sphere component has a mesh filter. Mesh filter. That's cool. Let's call it MF. And it also already has a mesh renderer. Of course, it's mesh renderer here. All right, so we have the mesh just by doing mesh M equals to mesh filter dot shared mesh. Instead of having this in this local function, let's just move that out for simplicity. We're going to declare the mesh here. Of course, we can also predefine that in the editor instead of doing that dynamically. But let's do it. Let's do that dynamically. Let's destroy the mesh we just created, the game object, because we don't. Let's not remove it. It doesn't really matter. Let's remove the moving part. And here, nothing should happen. So we just created the game object, but we are not rendering anything. So to actually do the rendering, there is a magic function called draw mesh instance. The mesh instance is gonna ask for the mesh to instantiate. So let's use that. It's gonna be using a material. So let's get the material from here. Once again, we're gonna declare the material here, just because I'm too lazy to do that properly. Material is attached to the mesh renderer. So material ml shared material. We're going to put the material here. And it also asks for the transformation matrices that we already created and filled. So let's add that in the update function, because we want to draw the mesh each frame, of course. So if I didn't messed up, yeah, I don't have any error or anything. I'm just checking that my script is still there, and let's try it. Okay. So of course they are not moving anymore because we removed the moving part. It still has few batches. It's actually really good, and we should have good performance too. Once again, if you want to to actually have an accurate idea of your performance, you shouldn't do that in the editor. You should do that outside. Create a build, launch the profiler, and yeah, do that outside of the editor. All right. So now let's try to crank it up a bit. So let's try to add, let's say 5,000 spheres. And we should have an issue here. No spoiler, but we should have something popping here. Yeah, all right. So it says that we have more than 1,023 objects per batch. So this is a limitation in Unity. We only can render 1,023 objects per batch. So here, this is way too much. Basically, we have way too much transform matrices is larger than one this function can accept. So to improve that, so let me check the time. So I don't have much time, I think. To improve that, we're gonna copy paste this. So let's create a new script again. Script C#, and let's call sphere instancing 2. Also, I didn't mention it, but it's working because we already clicked the enable GP in the material. So if you don't check that and you call the draw mesh instance, it's also going to be throwing some errors. Right, so I created my script. I'm going to edit it, copy paste what I already coded. All right, let's use 5,000 sphere here. And we're also going to create a new scene again, just so that, oops. Let's call it scene tutorial scenes 4, I think. Yeah, 4. Once again, we create the chem object. We add the script. So instead of drag and dropping here, we can use the add script button, add component button, sorry. I don't even remember the name. I think it's for instancing 2, okay. And okay, I save the scene. And let's do some coding. So instead of having 5,000 transform matrices in one draw mesh instance call, we're going to separate these transform matrices into batches. And the limit we just saw is in Unity is batch max batch. It's 1, 2, 3. 1, 0, 2, 3. It's 1,023. So instead of having transform matrices array, we have an array of arrays. Let's call it batch, just to be sure that we don't mess things up. So here we create, let's create a temporary array of matrices. Oops. Okay, and we are gonna fill the array of arrays here. So how do I do that? I need to know how many batches I will need. So I just need to compute. So sale to int is basically sale the value I'm gonna compute here. This is n spheres divided by the number of maximum batch that we can do. So here we have the number of batches. We still need to compute the position. We still need to compute the matrix. We fill the array of matrices, and we're gonna separate these matrices in batches. So let's do that. We need to create. oh, I didn't allocate this, so I have to allocate it. But basically, it's going to be an array of matrices with the size batch length. The batch length is usually 1023, but the last one should be shorter. Yeah, so it's the minimum between a batch max and n spheres minus start ID. And now start ID is basically the ID in the batch. All right, so I need to allocate this. Oh, so I need the number of batches to allocate it equals new, let me check. Oh yeah, so I need an array of arrays, and I need batches array of arrays. All right. So I allocated the matrices here, and I will fill basically the transform matrices. Yes, with, oh, I can just use a system array with compile. Transform matrices is the sources. I'm going to start the start position. This is the output, and this is how many copy I will do. Oops. Batch length. Okay. So now I should have an array of arrays of matrices, and I should be able to just change that and use that in the loop. So to do that, I of course need to loop over all the batches that I pre-computed. Sphere and spheres. Oh no, actually batches. So we're gonna need the number of batches again. And to do that, I'm just gonna copy paste this. Okay. And I'm gonna call this magic function again, graphics draw mesh instanced. This is basically the same thing. Sphere mat. Oh, actually material. The batch matrices that I will get, and how many batches I will do in one call. So of course I need to know the batch length here, batch length, which is basically the same as the previous one. So let me just copy paste. Oops, typo here. Okay. And okay, that should be good. All I need to get this array that I already computed. Batch matrix equals, so I need to get the correct matrices. Okay, so now I have my array, and I should be able to draw for each batch's batch length spheres. Let's clear that. Oh, a lot of typos, I guess. Don't even know where. Okay. Batch doesn't exist. Okay, because there is a typo here. And start ID doesn't exist because I forgot to add it. Okay. So now it should work, and I think I will stop there. All right, so I have a few batches. I have 5,000 sphere, but I still have a small amount of draw calls, which is good. And yeah, you have basically a nice example just to see how easy, but also how hard can it be in Unity to draw spheres, but also to import data, to create some random movements and to move things around. Of course, I can add the movements here. So instead of just getting the matrices, I can modify the matrices here and change the position of the spheres at each frame. I didn't show also how to modify the mesh, but it's also something you can do in Unity just by getting the vertices information. So if I use vertices, you get an array of basically of vector 3 vertices, and this is an array. So you can basically change the position of this first array and add it. Let's say, I don't know, this value, and this should work, because if you use mesh.vertices equals vertices, now you just modified the vertices of your mesh. This is also something I really want to do. Usually in scientific visualization, you have procedural mesh generation, and you kind of want to do that frequently. So in Unity Mall, we also create some meshes, and to do that really fast, we use the C# burst compiler thing, just to be able to do that on multi-threads and on the using vectorization. And this is now quite fast, so you can create really large mesh and modify them interactively during your loop, your update loop in Unity. So I hope it helped you just get an overview of how to do things in Unity, to start and to just get an idea of how you would do things, how you would load data and move things around in Unity. And I hope I can answer your questions afterwards. Of course, there are a lot of things I didn't cover, like UI, sound, interoperability, asset management, these kind of things. There are a lot of tools in Unity. I cannot cover everything in one go, but I hope it gives you a nice teaser to get started. So Michael, are you here?
Yes, I am.
Okay.
So, any questions still waiting for you? As I mentioned before, everyone who is in the Zoom can also turn on their microphone and ask questions directly if you don't want to type anything. Okay, then maybe I, of course, have the same questions I also asked in the very first talk. So what was your decision to choose Unity over Unreal Engine? Because I think Unreal, as Patrick said, is, I guess, the even older engine. So it was around back then. So what was the specific choice here?
Well, I think, so it was Mark's ID, Mark's Baden ID. I think at the beginning, Unity Mall was just a sort of prototype, just to see if we can use game engines, a sort of side project to prototype, to try it and see how it goes. So I think the Unity was already shown as a simpler way of accessing a game engine and do some visualization in that. So I guess that's why, but we have to ask Mark at some point. I guess the idea was to have a simpler UI, simpler scripting language, and not ask students to develop in C and start with something really big that can do really great things, but that is quite harder to learn, at the beginning.
So No regrets for that decision.
No regrets. So there have been some good and bad. But as I said, usually you have solutions in Unity. You have a lot of things in the community. You have a lot of assets. You can still do some really hardcore coding and GPU stuff and GPU. For example, you can do some compute shaders and things like this. So you can go really deep inside Unity. Hopefully you don't need it, but you still can. So that's always good. But I agree, compared to Unreal, for example, not having the source code can be troublesome if you really want to do some really in-depth things.
So may I just chip in on a thing here? So anecdotal evidence is that I often come across like prototypes done in Unity, but when I watch like polished, finished, like real working things, it's often Unreal that's been used. Maybe a little bit provocative, but and I of course looked more into the Unreal kind of feed of things. So I'm in my Unreal bubble a little bit, but yeah, that's one of the things. It's easy to get going. I mean, I can really see that. But then you run across small quirks that you have to batch up and do things like that. And yeah, that was just a small comment on the prototyping side. I see a lot of prototypes, proof of concepts, but when you see something that's actually been used by like car folks or like really, then they'd be using Unreal more often, I think.
I think one of the big selling points, so to say, of Unreal some time ago was that they were adopting a lot of or integrating a lot of support for head-mounted displays, so augmented and virtual reality, right? I had the impression that Unreal was getting on this a little bit later, right? Maybe that's also just my bubble.
I don't know. I think for sure Unity is really up to date on the VR side, just because as soon as you have a new headset or a new technology, usually you have a Unity plugin to do that. And I think that's also because the Unity team is is trying to push that and do some partnership to, as soon as there is a new prototype of VR gloves or whatever, they kind of want to have that in Unity. It also goes both ways. You want the people to, if you have a new haptic arm or something, you kind of want people to use it. So the best way to do that is to provide a SDK to a game engine. And usually Unity and Unreal are the big actors in that. So yeah, I guess that's also true. I would say that yeah, I mean, we tried, so we are quite involved in the VR visualization, and as soon as there is a new headset, it's already working on Unity. I'm not sure about Unreal, so maybe Patrick can discuss that.
Yeah, I think my feeling, I should say, in terms of supporting new devices, that seems to be pretty equal between the two. Just a comment back, one of the my motivation for going with Unreal was the licensing part, that it's free to use. And since we're doing not purely academic work and educational stuff, also doing like things for our dome and our exhibit, which could be considered commercial or not purely academic. we're being hit by the license of Unity, for instance, since we're such a large organization, and even the people at the municipality company are considered part of the municipality. So I mean, they're enterprises, all of us, and have to pay the enterprise license, which is kind of problematic.
Yeah, I agree.
I see one more question in the Discord channel. So how much behind is the current version of Mono as opposed to the reference.NET implementation?
Well, that's a quite technical question. I would say it's quite behind. Of course, you don't have the same features at the new .NET Core versions and not the same performance. But it's also something that is balanced by the fact that they propose a sort of different framework, to do some what they call HPC, so HPC sharp. So it's basically a high performance C#. Mm-hmm. So I don't think it's, I mean, if you are really a hardcore .NET coder, then it might hit you, but usually people don't really care about this stuff because they don't do data processing in Unity. They can do it using this platform or even C# or native plugin, as I said, but usually it's not so much a big issue, I would say.
Okay. I think the other question that came up, we already kind of discussed this, right? So how Unity compares to Unreal nowadays. You already shared your thoughts on this one.
It's also a really hard and large question to answer. There are so many, as Patrick said, there are some tools and different sets of things you can do in Unity and Unreal that it's quite hard to compare. Now even Unity has different rendering pipelines, so how would you compare Unity to Unreal? Do you compare the high definition rendering pipeline or the mobile oriented version? So it's quite hard to answer, actually.
So let's see. So well, if there are no more questions, I think we can thank Xavier, and both Xavier and Patrick actually again for giving this tutorial. Thank you guys. It was amazing. It was very interesting. And I could imagine that some late questions will pop up in the Discord channel during the next days. So it would be great if both of you could check this from time to time. And
we will be there.
That would be cool. Okay. Well, okay. I would say this concludes this session. I again want to thank everyone who joined us during this afternoon for coming. And yeah, I hope we will see everyone back tomorrow and in the next 3 days for the main conference. And yeah, so that's it for today. Thank you.
Hi, my name is Morris, and I present a teaser for our paper, Observer-Dependent Lossy Image Compression. If you compress an image, then often it is viewed by different types of observers, which can either be human or computer vision systems, such as image classifiers. The majority of research has so far focused on the human observer. In this work, we ask, can we optimize compression explicitly such that classification accuracy is maintained and trade off compression